Good day everyone, I am April, your future educator. In this video, we are diving into the unit circle, a fundamental concept in trigonometry. Are you ready to explore it with me? Let's go! Vamonos! Today's learning objectives. Understand correct mathematical notation and terminology. Accurately define and draw the unit circle while identifying k-coordinates of special angles. Recognize and understands the 6 trigonometric functions and their value limits using the unit circle. So what are you waiting for? Grab your notes, stay focused, and let's make learning fun. Let's begin. Let's focus on the unit circle. The unit circle is divided into 4 quadrants. The quadrant 1, the quadrant 2, the quadrant 3, and the quadrant 4. In quadrant 1, both sine and cosine are positive. In quadrant 2, sine is positive but cosine is negative. In quadrant 3, both sine and cosine are negative. In quadrant 4, cosine is positive but sine is negative. So we have here the y and x-axis. Y-axis is associated with sine and the x-axis is associated with cosine. This is an important fact to remember when working with the unit circle. So in quadrant 1, we have 30 degrees, 45 degrees, 60 degrees, and 90 degrees. In quadrant 2, we have 120 degrees, 135 degrees, 150 degrees, and 180 degrees. In quadrant 3, we have 210 degrees, 225 degrees, 240 degrees, and 270 degrees. In quadrant 3, we have 300 degrees, 315 degrees, 330 degrees, and the 0 degree and 360 degrees is a coterminal angle. Now, let's add radians into the unit circle. So, first, 30 degree and pi over 6 is the same. 150 degree, pi over 6, and 210 degree, 7 pi over 6. And in 330 degree, 11 pi over 6. So all these angles shares the same reference angle of 30 degrees. Now next is 45 degree. So 45 degree is same as pi over 4. 120 degree, 3 pi over 4. 225 degree, 5 pi over 4. And 315 degree, 7 pi over 4. So they share the same reference angle of 45 degrees. So now let's have the 60 degree is same as pi over 3, 135 degree, 2 pi over 3, 240 degree, 4 pi over 3, and 300 degree, 5 pi over 3. So for 90 degree, we have pi. For 180 degree, pi, and 270 degree, we have 3 pi over 2. And for 360 degree, we have 2 pi. To fully understand the unit circle, we need to know the x and y coordinates of these angles. So, since the quadrant 1 x and y axis is both positive, so we have, for 30 degrees, we have root 3 over 2 and 1 half. In 45 degrees, we have root 2 over 2 and root 2 over 2. In 60 degrees, we have 1 half and root 3 over 2. In 90 degrees, we have 0 value for x and a positive 1 value for y. So in quadrant 2, x-axis is negative and y is positive. So we have here negative 1 half and root 3 over 2. In 35 degrees, we have negative root 2 over 2 and root 2 over 2. In 150 degrees, we have negative root 3 over 2 and 1 half. So in quadrant 3, both x and y axis is negative. So since 210 degrees share the same reference angle of 30 degrees, so we have the same value. So we have negative root 3 over 2 and negative 1 half. So in 225 degrees, so 225 degrees is same reference angle of 45 degrees. So we have the same value but negative sign. So we have root 2 over 2 and negative root 2 over 2. In 240 degrees, we have negative 1 half and negative root 2 over 2. So since 270 degrees is opposite of 90 degrees, so we have here 0 and negative 1. In quadrant 4, x-axis is positive while the y-axis is negative. So since 300 degrees is same reference angle of 60 degrees, so we have the same value. So 1 half and negative root 3 over 2. For 315 degrees, we have root 2 over 2 and negative root 2 over 2. In 360 degrees, we have root 3 over 2 and negative 1 half. So, to determine the values of the 6 trigonometric ratios, we must first define the parts of a right triangle. Let us consider a right triangle with a side labeled with A, B, and C. So as we can see, the right angle is located in the side of a C. So it means that the hypotenuse is the opposite of the right angle. So this is the hypotenuse. The identification of the opposite and adjacent side depends on the chosen acute angle. A right triangle has two acute angles, the A and the B angle. The opposite side to the angle A is the angle BC, so this is the opposite side. And it means that AC is the adjacent side. So now, let's define the 6 trigonometric ratio. A common acronym used in trigonometry to remember this ratio is the SOHCAHTOA, which stands for S for sin, and O for opposite, and H for hypotenuse. So, C for cosine, A for adjacent, and H for hypotenuse. T for tangent, O for opposite, A for adjacent. Let's get the formula of this trigonometric ratio. So we have sine is equal to opposite over hypotenuse. We have the cosine, adjacent over hypotenuse. We have tangent, opposite over adjacent. In addition to these three primary functions, we also have the reciprocal. So the reciprocal of sine is the cosecant. So the cosecant is hypotenuse over opposite. In the reciprocal of cosine, and we have for cosine, we have secant, hypotenuse over adjacent. And for tangent, we have cotangent. Let's try to solve the trigonometric function for 45, 45, 90 degree triangle and define the x and y coordinates. In this type of right triangle, both legs are equal in the length, and as we can see, the hypotenuse is missing. To determine its value, we apply the Pythagorean theorem. Which state that a squared plus b squared is equal to c squared. So, in order, the Pythagorean theorem, which state that a squared plus b squared is equal to c squared. So now let's solve for the hypotenuse. So, a is equal to 1, so it means 1 squared plus b squared is equal to 1. So, we have 1 equals to c squared. Now, we have 2 is equal to c squared. So, the hypotenuse is equal to the square root of 2. So which means that the hypotenuse of the right triangle is square root of 2. So the sin is equal to root 2 over 2. And for cosine, we have adjacent over hypotenuse. So root 2 over 2 is equal to root 2 over 2. For tangent, we have flip opposite over the adjacent. So it is equal to 1. So for cosecant, we have root 2 over 1 is equal to root 2. So per secant, we have root 2 over 1 is equal to root 2. And for cotangent, we have 1 over 1 is equal to 1. So that's the value of our 6 trigonometric functions.